Did you find any shortcuts in asynchronous? Synchronous anyway, it's a monotonous job. But synchronous, asynchronous, anything new? What happened? So all of that? Okay, you have come, right? Okay. So today what I wanted to tell is one important problem. Yeah. So what important problems are there? Right. Okay, still joining. Anyway, I will share that. Okay, so let's start working one problem. There are some, just a second. Okay, so now yes. Yeah, I'm sharing this problem. Just see. Right. So once I discuss this problem, afterwards, Swaroop, surely I will discuss your problem. Are you guys there?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now just check out. This is some flip flop, means you should have the confidence that we will have a flip flop. We can design a flip flop. Okay. So some new flip flop called X1 is defined. Okay. Now the characteristics of the XY are clearly given. Right? What is that? When XY is 0, 0, the flip flop changes the state with each clock pulse. If XY is 0, 1, the flip flop's state Q becomes 1 with the next clock pulse. When XY is 1, 0, the flip flop state Q becomes 0 with the next clock pulse. Okay, so now this is simple clues they are giving. Right? Now, such type of problems, if at all we get. Okay, otherwise we wanted to design our own flip flops. Right? First and foremost, if you remember, we have to understand this. What is happening means every statement is given to you. Okay, and how exactly we can analyze in that? Q of t you can take and Q of t plus 1 also. What? Right, because every state will have two options. Is that correct or not? Hello? And so
Yes, ma'am.
Yes, ma'am.
a new flip flop, we are designing a new flip flop. Please try to understand. Okay, so when XY is 0, 0, the flip flop changes state. Okay, what does it mean? What is the meaning of that? Because this type of things will come, 0, 0 will come 2 times. Right? One with previous one 0, another one with previous one 1. So it changes its state means maybe like this. Is that correct? The meaning of that?
Ma'am,
Yes, ma'am.
QT bar.
No. Not QT bar. I am talking about Q of t and Q of t plus 1.
So the flip flop changes its state that maybe QT plus 1 is equal to QT bar.
That's what. Yeah, that's what I wrote also. You can say, check it. You are not able to see my board?
Yes, ma'am, visible.
It's visible, na? That's what. See, I'm just trying to extract the meaning of that statement. So, XY00 will occur 2 times. Right? So, one with previous 00. See, this is the option. Right? With XY00, I have 2 options coming. And both the times, as per the statement, it is getting changed. So, if the previous one is 0, has to change. So, 0 means it has to change to 1. If it is 1, it has to change to 0. Is that correct? Easy? Right? Now, it's not in a continuous manner. Okay. Now, next one is 0, 1. 0, 1. Again, I have 2 options. Right. What it does with 0, 1? Check out. The flip-flop
1, 1.
state Q becomes 1 with
1,
the
1.
next clock pass. What does it mean? It remains 1. Is that okay?
Yes, ma'am.
It remains
Yes, ma'am.
1. Yes. So try to extract the meaning of that. So with whatever the previous one is, it remains 1. That's what they do. Okay.
Okay.
With xy 1 0, the flip flop state q becomes 0. Okay. Now, what is that? With 1 0, I have options like this. What will happen? It becomes 0, it seems. Right? Now I don't have space for 1 1. Okay, so again q of p, x and y. Q of p plus 1. With 1 1, what is happening? You tell me. With 1 1, no change of the state occurs. Means it remains as it is, it seems. So, whatever it is, it remains as it is. Is that okay?
Yes,
First
ma'am.
of all, did you understand? Yes. So now, maybe that pasting is a little wrong, so no change in that, blah, 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 something. Okay. Now, A bit. Give the characteristic table that we have already done. Write xy flip flop. Write the excitation table of it. Okay. Now, hold on. So, this is all we can say the meaning.
Ma'am, you are not audible.
Video is stuck.
Hey, one internet connection for me. You guys enjoy? You are enjoying?
Hello, ma'am.
Hi, Shweta. Shweta, no internet connection. These useless fellows have cut the internet connection. Okay, so there's some work going on. So I have no idea. Till where I blabbered, you have any idea? Like, did you understand this one when I was telling something you have listened?
Yes, ma'am. Up to characteristic table, it was okay.
Okay. You have to do the characteristic table, equation. Last one is okay. Now, whoever have completed can post also, no problem. It's interesting to design this way. Now I'll be seeing again. What's wrong here? Shweta. Hello.
Yes, ma'am.
There's some internet issues, ma. So I'll be going, coming on there. I think so something is going on. Seriously, we have no internet connection. I don't know how this is working. Or something. Okay. Anyway, so somebody has posted that. I'm checking out. Right, please bear with me. Somebody has posted where? Yeah, I think Suchira. Suchira has done the equation.
Yes, ma'am.
T plus 1. Correct? So
Yes, ma'am.
Yeah. Ayushman also has done. Okay, everybody is satisfied, right? You got the now the excitation table. Excitation table also, please. Yeah, so come on, go ahead. So you will get posted. So excitation table, I think it should be easy because characteristic table already know. What is the excitation table format? See, characteristic is already known.
Yes, ma'am. Posted.
Yeah, Q of t plus 1 you can do. Yep. So if at all you can do Q of t plus 1, then it's xy. So you will get the excitation table for this. So once that is known, the fourth one is important. Like what is that? You need to do the conversion. Is that correct?
Yes, ma'am.
Yeah, please work on. Convert a JK flip-flop into XY flip-flop by adding some external gates. That is for sure you require. Okay, so conversion of flip-flops, if you remember, this is just for practice we have to do because we are forgetting the old ones. Right. Oh, somebody has posted. Let me see. Okay, who has done? Salugna. Oh, good Salugna. Excitation table ready. Now conversion on.
Ma'am, I have posted the conversion also.
Ah, good. Where is the shared window? What is this fellow? I posted the conversion also. No? Salugna. Acha. Okay. So x is equal to j dash, y is equal to k dash. Everybody are getting the same? Oh, you have used some don't guess also. How did you manage to do don't guess?
Ma'am, from the excitation table.
In the excitation table, you will get the don't guess. How? Could you get the don't guess?
Yes, ma'am.
Saru?
Yes, ma'am.
You could get Hassan? Harsh? Are you
Yes,
able to
ma'am.
get
Yes,
We
ma'am.
will get
Yes,
don't
ma'am.
guess.
I'm done.
Okay. So conversion means like I want a flip-flop, not equations, not just a diagram. Diagram also you can show, diagram wise also it's good. Just a second, no one phone call is coming, you can convert it. Okay, otherwise. Sorry. What is that? Okay, you have completed already x dash and y dash. What Salugna has told is correct. I mean x is what? J dash, y is k dash. Is that correct? Everyone?
Ma'am, 1 minute doing.
Okay. So by that time, one more good problem is ready.
Yes, ma'am. X is J bar, Y is K bar.
Super. Very good. Salugna, very good. Okay. Now. So almost everybody has done. Now, I'm just pasting it for you. It is visible already. Now, this is the circuit, right? So I'm just showing the figure. Now, be ready for the circuit. This is the circuit. Determine the functional behavior of the circuit, which is shown in this figure. Okay, figure 2 is something else. Okay, in the figure. Everyone, are you able to see this figure? Assume that the input W is driven by a square wave signal. Okay, square wave or pulse. Let us consider. Okay, so this is the signal. I mean, this is the complete sequential circuit. FF0 means first flip flop, FF1 means second flip flop, FF flip flop 0, flip flop 1. Okay, it's a name, right? So its output is Q0 and Q1. So you can understand this. This is a control, W is the control signal it means. Okay, which is connected to the clock pulse. So indirectly clock pulse is given as W. Is that correct? Is that correct or not?
Yes, ma'am.
Yes. And we have a clear also, doesn't matter, right? But I wanted to understand what exactly this particular sequential circuit is meant for. I mean, the functional behavior. Maybe it represents a counter, or maybe it represents something like what I should say, some application-oriented outputs are coming or what. Can you just think about it? How it works. So, in order to understand such type of circuit, what you have to do, you have to analyze what is Q0, what is Q1. Is that correct? What is Q0, what is Q1, you have to analyze for every clock pulse. That means timing diagrams you have to draw. Right. This is a little complicated. See, we have a circuit. Okay, we have a circuit. Both are JK. This is W, it seems. Okay, doesn't matter. So this is Q. So this particular one is fed here. Okay, and now K is high, K is high, J is also high. This is what provided there. Oh, no, J is not. Oh, interconnected. Okay, so now what exactly the Q naught, Q, right? You have to analyze
Ma'am, video got stuck.
Priya, Abhijit, yes.
Yes, ma'am. Audible, ma'am.
Okay, right. Are you able to get what I was telling here? See, question is you are given a sequential circuit. This is the format already provided to you, right? You have to analyze what exactly this functional behavior. Indirectly, they are what Q naught. Right. This way is everything. Then you can analyze what Q naught and are you able to understand for every so horrible network is going on now today here. Actually, original internet network is there. Internet is there. I don't know why they are. Like constant. They are switching something. Okay. Shweta,
Yes, ma'am. Yes.
see, there is some from BSNL and this one they are taking networks. I don't know why. Okay, there is some glitches going on. Okay, either anyway, doesn't matter. So some work is going on, doesn't matter. So now, can you identify what I was trying to tell? I was trying to tell why can't we draw the timing signals with respect to W? Okay, now since they have already given a clue that with respect to W is the clock pulse. That means the control signal. It's pointed out already. So with respect to that J0, K0, J1, K1, Q0, Q1, everything I want. Timing diagram. Anybody did? Or still doing? Okay, somebody has posted. Figure 1 converted to J3. Okay. They are correct or not. Swaroop has a doubt. Swaroop?
Yes, ma'am.
So you are not getting like that?
Ma'am, for the previous question, last part, the conversion of JK into XY flip-flop.
That's
So-
what the conversion of flip-flop. How did you do? A JK flip-flop has to be converted to XY.
Yes, ma'am. Ma'am, for that, I created a table that include both characteristic
Your
table of
characteristic
XY.
table is wrong.
Okay, just post that table. How it is? Hassan,
Yes, ma'am.
you wanted to tell something?
Yes, ma'am. His characteristic table is wrong, ma'am.
Oh, his characteristic
No,
table.
ma'am, I think Swaroop is correct because for conversion of JK to XY, we have to take XY as input, right?
Obviously, na.
So I think Swaroop's is correct.
JK has to be converted and work as an XY. So
Yes,
JK
ma'am.
should be what? JK has to be converted. Means JK is available and now it should work like a XY.
No, ma'am. No, ma'am. It's his conversion. Like his conversion technique is right. But his characteristic.
He is telling conversion technique is correct. His characteristic table is wrong.
So answer is wrong.
Oh, check that one, please. His
But I'm
conversion table
also,
is correct. Yeah, please do that.
ma'am, I'm also getting that. So I was saying.
Oh, you are also getting the same thing. Oh no. Some we got the third empire. No. Who else is there doing?
Ma'am, I think uh, our available flip flop is XY and the required is JK. So we have to make a characteristic table of XY and
No,
excitation table of JK.
स्वरूप तेरा
हाँ,
कैरेक्टरिस्टिक टेबल रॉन्ग है, बाकी तेरा प्रोसीजर राइट है, बस कैरेक्टरिस्टिक टेबल तेरा देख रॉन्ग है वो
That is what Bharat is telling. Your procedure is correct. See, I was telling you conversion of table is there, na? You have to convert JK flip flop to XY flip flop. What did I give there?
yes ma'am, JK to XY.
JK to XY, right? So JK to XY. This is what given. Is that correct? JK to XY means who should be the input? XY should be the inputs. That is correct. You did it. So J and K is available. These are inputs. 100% correct. So how the characteristic table should be? XY this is how it should be.
Ma'am, the
Is that
table
correct?
is, ma'am, if he should have taken Q1 and XY, he took XY QN.
I didn't understand.
Ma'am, the table, the starting of the table, he took XY and QN, ma'am. But before that, before drawing the table, he took QN, X and Y in that form, and he changed here. That's why he got wrong.
Yes,
Okay.
yes
Right.
ma'am, I
He
understood.
changed the LSB and MSB. Be careful, ma, with that.
yes ma'am, his whole characteristic table is wrong, that's why the answer is coming right wrong, I mean.
Okay. So check out characteristic table when I have followed the format I am following. So please follow that only. Conversion also like this. Keep this one as a format. Okay. If you change the LSB and MSB, everything will be totally mishap. Good observation. Okay. Now get back to my new one. I am much excited about this problem. This problem, I want the timing diagrams. Old story done, no issues. See, the timing diagram of J naught, K naught, it is a very interesting problem. Please try to work out. J naught, K naught. Then afterwards, immediately I will go to the Swaroop's another one. What is that? So it has pointed out something. So, anybody started this one? This problem?
Yes, ma'am, do
Oh,
it.
characteristic Q became the LSB. Right. Okay, that's the reason everything has gone wrong. So your midterms will be changed, Nama. Obviously, then accordingly it will change. Midterms, because you are using K-map, midterms notation is changed, then everything will change. Good. Right, at least right. Very nice, very nice. I think
Ma'am,
Suratna,
can
you
you
also have done the
explain?
same thing. Priya?
Ma'am, can you please explain that again because I'm still getting the same.
What is there to explain now? I'll tell you
Ma'am,
the.
see, I had taken XY, QT and QT plus 1 for the
No,
excitation.
that is wrong, no? I have to take characteristic table is like this. This manner I took. Characteristic table should be like this. Q of t should be the MSB. You made it NSB.
Ma'am, but if even if I write like that, if I take the excitation table,
No, once you finish this one, excitation table is what? Q of t plus 1 and xy you are telling. So that has no role there. See, Q of t plus 1, xy excitation table, what role you will have there? It will change, no?
so I'm taking the excitation table for JK is required in this, right?
For the excitation table of JK only is required. Obviously, see, I have written now. X, Y, Q of t should be there and JK should be given here.
Yeah, ma'am. So first term will be 0, 0, 0 and then 1
Hmm.
and 1. And for the excitation table of JK,
Hmm.
Since QT
No,
is 0 and QT,
no. When xy is equals to 0 0, then your output is toggling, and you said 1 1. It's not 1 1. When your input is 0 0, it's toggling. So you have made a wrong characteristic table. That's it. Otherwise, answer will come right. Your procedure is correct.
means it should be 0 0 1 1.
No,
The
no.
first input.
When it is 0 0 0, then it is 1. When there is 0 1 0 1 0 0 1, then it will be 0.
Hold on. Simple thing. Sulagna, is that you?
No, ma'am.
Who is that?
Oh, Priya, ma'am.
Okay, Priya, do one thing. You again scrap out all whatever you have done, right? Otherwise, verify this manner. First, prepare a characteristic table in this format with the statements what I have given. Q of t, x, y, and it's q of t plus 1. Okay, first complete this. Then prepare its excitation table like this. Q of t plus 1, and it's xy. Right? Okay, then convert that x, y, and q of t plus 1, and it's jk. Q
Ma'am,
of t.
I did exactly
Ma'am,
like that. I
ma'am,
did that only.
the problem is not
Ma'am,
this. The problem is they have not read the question correctly and they are making wrong characteristic table. That's it. No problem with the table and procedure and all.
So what I should answer for this? Okay, question again. Who's that? Better?
Salangana's table is right. Whosever doubt is, you can check Salangana's table.
Oh, okay, I'll do so. But ma'am, if you could post the answer, then that will be better.
What is that? This regular answers. Okay, I'll write it and then post it better. That's better. Okay, see, this is the question. I posted that question. Right, convert JK flip flop into XY flip flop.
Ma'am, can we proceed?
Yeah, true.
Yes, ma'am, proceed, please.
Yeah. Okay, so right. Where are we now? Yeah, we are with this question. What is that question I'm giving? Yeah, this one. Yeah, determine the functional behavior of the circuit. Is that correct?
Yes, ma'am. This.
Yeah, determine the functional behavior of the circuit. And then assume that the input W is driven by a square wave signal. Okay, so here what we are trying to do is we are trying to work out this outputs with respect to the W. That means indirectly we are analyzing the sequential circuit. Right. So are you able to draw the circuit like this? I mean, these timing diagrams. Other than this, there is no solution for this. We have to go through the what? What I should say? It's timing signals. We don't find any other solution. Is that fine?
Yes, ma'am.
Yeah. So anybody started the timing signal? What is it? Okay. So now K will be high always. For every clock pulse, it is high, no change. Okay, so that means K naught. K naught means this first flip flop. Okay, this flip flop. I'm talking about this flip. Okay, so now J naught, K naught, J1, K1, Q naught, Q1. Okay, so now how we will start with? We should start with a pre-decided. Just a second. Anybody has started this problem?
Yes, ma'am.
Anybody has started this
Yes,
problem?
ma'am. Yes,
Yeah,
ma'am.
how-
Yes, ma'am. Ma'am,
Okay, so it is working as a 2-bit counter.
yes, ma'am. 2-bit synchronous counter.
Yeah, that's all. That easily I can tell that. But how we are starting with? Did we have
Yes,
a
ma'am.
predetermined Q naught and Q1? See,
Yes,
question
ma'am.
is yeah.
Ma'am, first I write the equation of JK flip flop that Qn plus equal to JQn bar plus K bar Qn.
Since it is synchronous now, that's what. J naught instead of the first starting before this, please try to write J naught equal to K naught equal to. Okay, then J1 equal to K1 equal to equations, state equations. Okay, so flip flop equations you write, right? Then afterwards I think you can do that. Once you write the equations and in Q naught, then you don't require this also. You only require Q naught and Q1, right? Since it is directly what? Directly linked. I mean, it's a synchronous counter, isn't it? Then is it working as a 2-bit counter? What is the equation of J naught? So what is J naught equation? Are you guys there? Okay, somebody. Ashirvad Das,
Yes, ma'am.
what is this now? What is this force supposed to do?
Ma'am, I guess we have to just consider J equal to something or Q1 equal to something. Then the flip flop will work flip flop will work.
As a 2-bit counter.
Yes, ma'am. No, ma'am.
Toggles.
Ma'am, we have to consider Q1 or J equal to J equal to 0 or 1 as an initial state.
Initial we have to start. Otherwise it will not.
So we will take J.
See, just a second. If at all you are observing, Q bar is connected to J now. This Q naught will come only if at all I feed here. If at all,
That's
yeah, if it is there
first-
only you have to.
First we have to feed for J, then circuit will work accordingly. Like
See, if you start J equal to 1, if you start J equal to 1, means from Q bar it has come 1. Okay, so 1, 1, then Q naught will be there. That output only is getting here. So 1, 1 is there, Q naught output as well as same thing will come because synchronously it is working. No? Q naught and Q1 comes at the same time. Isn't it? Q naught, Q1. If J equal to 1, consider. Okay, J equal to 1, what will be this?
This will be toggle. Like it will depend on state of. It will be toggle, na?
It will be previous state. Okay, initial setup you want to do. Right?
So
initial setup. That's
to
what initial setup we have to do. Okay, so consider these are all Q naught, Q1.
Ma'am, let's take J equal to 0.
No, this all has to be there. See, first two is 0. Consider this stable states. Right? So Q naught is 0, Q1 is 0. Okay. So Q1 is 0 means Q bar is 1. So that has come. Right? So at the first one, what will be?
No need to do other things. That's it. Q naught and
No,
Q1.
we will try to tell them. Otherwise, they cannot understand. So Q naught and Q1. This is initially 0. This is initially 0. Then it turns out to be 1. So when it has come, the first clock pulse, then what will be the output? It is 0, 1, 1. What is the condition? 0, 1, 1 condition of the characteristic table? Please tell.
What, ma'am?
1, 1.
0, 1, 1 is 1.
1,
Okay.
1.
So that means it will go to 1. Okay. Q naught will go to 1. Right? Similarly, 1 has come. Q1 also. This is Q1. Not initially it is 0, but now it is Q1. It is also becoming 1. Is that correct? Right? Now the system has to run. So this is 1. This will be 0. So now 0 is fed to here. Okay. In the second clock pulse, it came 0. 0 has come here. In the previous one, this is Q naught is 1. Okay. So what will happen now?
It will go to 0.
Yeah, that's what. It will go to 0. Okay, so it came to 0. So it goes to 0. So what is happening? 0. This J2?
Same 0.
Yes. Right. So now this is very important to tell that starting you have to presume. This is presumption. Right. So now 0, 0 it has come. So this is going to 0. This will be 1. So it will come as 1. So if it is coming as 1, output is goes to 1. So this is 1. J is also receiving. This also goes to 1. Is that correct?
Yes, ma'am.
So
Ma'am, initially we have to take clear equal to 0. That's it.
That is provided. So that one you have to mention there. See, simple thing is, if you at all you start with this. Now, not necessarily you have to start with 0. Please try to understand. This same logic can be worked out in different manners. Initially, this one need not be 0. That is need not be fed. Okay, initially you can keep any value. Starting stable itself is high. Then you can see your timing sequence how it comes. Please try to understand. You can work this problem in different manners. Starting state, you can take anything, then the sequence will continue. It's not necessary for this particular section, only this we have to do. No, definitely not. Right? Please try to understand this particular thing. Okay, any presumption, even if you start with high, then the clock will work like that. Now finally, what is this? Now finally, what is the circuital behavior? What do you want to tell in this? Yes, what do you want to tell in this?
Ma'am, it's like 2 1-bit counters.
2 1-bit counters. Okay, you can see. This is up to you. And when you start with the stable state 1, is that also same thing coming in? That you should work out. Stable state with different value. Now let's see what Swaroop has posted something. Okay, he was telling to discuss on this one. Construct a state table for the circuit and identify the stable states for the circuit. Okay, right. So yeah, this problem anybody has worked out? Nobody has sent me this one.
Ma'am, we have to find just functional behavior. Now we have done with that.
Oh, not this functional behavior. Swaroop has posted something. Okay, let me share. Swaroop's postings was something different, man. Earlier one problem I had given now. With the multiplexer. How I should share this?
Ma'am, I tried the second question first part. Only that part I can able to do.
No. What is that we can discuss? We have 5 problems. So one problem I can discuss. Wait a minute. What is that you have told? Yeah, this question is very easy, right? Once the timing diagram starts. Right now, I think you people are getting some. Okay. So you have 2 multiplexers, right? And 2 multiplexers are we have a selection pin. First part. What is the first part? This is select pin. This is select pin. Are they interconnected? This is 2 by 1 marks, na? Yeah.
Video was not visible. Video is not visible.
Yes, ma. There's a bad network quality they are telling. Swaroop, can you just post that one? Yeah, there is no network actually. Without network, it is going on. How problems?
Yes, ma'am. I can post. Which question? There are 2 problems. One with multiplexer and one with.
I'm posting. I'm posting. Just sharing that. Stop sharing this. It's very bad quality network today. Morning class also, it's what happened. Yes, you can check this. Now, for this particular circuit, now I think share is there. Okay, construct a state table for this circuit and identify the stable states of the circuit. Okay, so anyway, forget about the question. Now, what do you analyze from this? There are 2 multiplexers and the 2 multiplexers are interconnected. Yes, all everybody there? Very important question it is. Guys are there?
Yes, ma'am.
Okay, so anybody has tried this? 2 multiplexers are there, 2 by 1 multiplexers. Okay, so in 2 by 1 multiplexers, what is that? Interconnection is there. The outputs are interconnected, right? This output is serving as an input to the other, and that output is serving as an input to this. And the select lines are there. Very tricky question. Actually, it's working like a flip-flop. Its output is serving as an input, and its output is serving as another input. Yes. Okay. Fresh input, there's a fresh input. Select line is there. Select line is there. 2 by 1 marks, 2 by 1 marks. This is Q0 you take, this is Q1 you take. This is I0, this is I0. This is the circuit. This is exactly a flip-flop in terms of multiplexers we have given. Correct. Just see. Select line 0, select line 1. If this is 0, consider, then we will get one signal here, that means this is activated. This will not be activated. Because single select line, mux 1 will be activated. Select line 1 means mux 2 will be activated. Is that correct? So mux 1 is activated, Q0 will come. Q0 will be there. Okay, so that will be serving as input. See here. Here the question comes, this one will be interconnected. Whatever the select lines are, so multiplexer 1 will be activated and given. But we have to understand a predetermined state should be there. Here also there should be a pre-assumption. Don't you think so? Because see, it is connected, no? Input is connected. Yes or not? It's a flip-flop. Actually, it's a oh, but I have explained so much. But I was not in the meeting. Hey guys, there or you have left already?
Ma'am, many have left.
They have
And
left.
at the
Oh,
flat,
I was trying to explain so many there. I don't know when. And there's a network issue. I cannot help. Now see, I was trying to explain. This is actually a flip-flop working in the select line first, then the multiplexer 2. And if you can check out, they are interlinked. Q0, Q1, Q0, Q1. Both in both the cases they are repeating. That means we have to start with the initial guess and then work out. Don't you think? This is a flip-flop. Please identify that.
Yes, yes, ma'am. Yes, ma'am. Means
This is a flip-flop. That's what I have explained so much. It's in a fragmented mode. That's all. It is a flip-flop. And then you can understand its characteristic table. How it looks. It might be resembling some SR flip-flop or JK flip-flop. Other than that, nothing. So no point in
ma'am, the
work out.
select lines are different.
Yeah, that's what now. When select line is 0 and select line is 1. So multiplexer 1 will be active and multiplexer 2 will
Ma'am,
be active.
for
This
the
is
first multiplexer, it's A and the second one is B.
select lines are different.
Yes, ma'am.
Just a second. Oh, okay. A and B. Okay, no problem. I was thinking select line. So this is A, this is B. So it has no role. So we can just take, okay, this is a clock signal. This is clock signal. To be honest, one is a clock signal. This is your clock signal, right? One is working in a negative pulse, another one is working in a positive pulse. Don't you think so?
yes, ma'am.
It is A,
For
B.
for this question, I made the point question 1 and 2. Means this question has 3 subparts, and
Huh?
for this question, I done part 1.
Analyze
As
the behavior of the circuit. Is this circuit useful? Okay, if not, explain why not. See, this is you have to understand. Okay. Analyze the behavior of the circuit. Is it resembling anything like any SR flip flop, JK flip flop, or anything? Or is it resembling any counter sort?
Ma'am, what I have solved is not resembling any flip flop.
Any flip flop. So what
Yes,
it
ma'am.
is resembling then?
Yes, ma'am. We can only form a state table, and from that we can write characteristic. We can write the characteristic
Okay, so
equation
that
that
was it's
Ma'am,
not
P plus
explained
one.
by.
ma'am,
See, it's not.
we
Yeah.
can take a equal to 1, and then we can proceed. Like it will work as it is. Just take a equal to 1.
Hmm. Okay, listen. So a equal to 1 if you tell me take. What is that you're telling, ma?
Ma'am, I'm just saying that take a equal to 1 and just analyze the circuit.
Okay. Equal to, you can analyze any, see, you can take analyze taking a equal to 1 as well as a equal to 0. Both ways you have to start.
For a equal to 1, it will be easy.
See, this is not the point of easy. Anything you can work out in that. Okay, he's telling something, so. Hey, you should be having some class, right? Okay, join your class. I will discuss it again later. Right?
Okay.
So join the other
Okay.
class.